Imagine waking up in a massive ancient mansion. You do not know how you got there, who built it, or why some rooms seem to defy the very laws of physics. You try to turn on a light, but instead, you watch the walls slowly drift apart. You look out a window, and all you see is an infinite, cold void. This is not a scene from a horror movie. This is the reality of the universe we live in right now. We like to think that modern science has it all figured out. We have the James Webb Telescope, the Large Hadron Collider, and supercomputers that can simulate the birth of stars. But the truth is, everything we can see, everything we can touch, and everything we are made of is just a tiny island of light in a vast, dark ocean of the unknown. There is something hidden in the darkness between the stars, something that cannot be seen, cannot be touched, and cannot be measured directly. Scientists know it is there, and they have known for decades. Right now, the universe is full of secrets so strange, so mind-bending, that some of the brightest minds on Earth are losing sleep over them. These are not small questions, but questions that could completely rewrite the laws of physics as we know them. Today, we are taking a journey into the darkest corners of existence to explore 8 of the biggest unsolved mysteries in the universe. These are secrets so strange they make us question the nature of reality itself. Some of them will make you feel incredibly small. Some will make you question whether reality itself is what you think it is. And at least one will make you wonder if we are truly alone. Get ready, because after this, the cosmos will never look the same to you again. And if you are ready to hunt for the truth with us, make sure to subscribe to the channel, where we look past the event horizon together. Let us start with something that is literally surrounding you right now, yet you cannot see it. In the 1930s, an astronomer named Fritz Zwicky was studying clusters of galaxies. He noticed something terrifying. The galaxies within these clusters were moving so fast that they should have flown apart, like water droplets being flung off a spinning carousel. He calculated how fast the galaxies were moving, and then he calculated how much mass the cluster needed to hold them together at that speed. The numbers did not match, not even close. There simply was not enough visible gravity from stars and gas to hold them together. Zwicky realized there had to be something else there. There had to be more mass, something heavy, but completely invisible. He called it dunkle Materie, dark matter. Decades later, Vera Rubin confirmed this by studying the rotation of individual galaxies. Stars at the very edges were orbiting just as fast as stars near the center, which broke every law of Newtonian physics we knew. Fast forward to today, and after nearly a century of study, we now believe that approximately 27% of the entire universe is made of this dark matter. It does not emit light, it does not reflect light, and it does not interact with light or absorb it in any way. It is passing through your body at this very second without leaving a trace. Scientists are building detectors deep underground, hoping to catch just one particle, proposing candidates like WIMPs, axions, sterile neutrinos, and primordial black holes. Every single candidate has been searched for, but none have been found. We know it is there only because we see its gravitational thumbprint on the things we can see. Galaxies rotate too fast for their visible mass, and light bends around objects that should not have enough gravity to bend it. It is like trying to study a person by only looking at their shadow on a wall. Something enormous is there, and we have no idea what it actually is. More than a quarter of everything that exists is made of something we do not even have a name for. That should terrify you, or fascinate you. Probably both. If dark matter is the glue that holds galaxies together, then dark energy is the invisible explosion tearing the universe apart. In 1998, 2 independent teams of astronomers were studying supernovae, exploding stars that briefly shine brighter than entire galaxies. They were using these explosions as measuring tools to map the expansion of the universe. Everyone expected to find that the expansion of the universe was slowing down due to gravity. It makes sense, right? If you throw a ball into the air, eventually it slows down and falls back. The Big Bang energy should be running out since gravity pulls things together. Instead, the cosmos had a different plan, and they found the opposite. The universe is not slowing down. It is speeding up, expanding faster and faster every single second. It is as if some mysterious force is pushing the fabric of space itself outward, faster and faster, with no sign of stopping. We call this force dark energy, and it makes up a staggering 68% of the entire universe. Think about that for a moment. 95% of everything in existence is dark matter and dark energy. That means everything you have ever seen. Every star, every planet, every nebula, every galaxy, your loved ones, this very screen, and every atom of matter in existence adds up to just a tiny 5% of the universe. The rest is two things we cannot see, cannot touch, and cannot explain. We are a microscopic impurity in an ocean of darkness. The universe is not mostly made of stuff. It is mostly made of mystery. And the scariest part is that dark energy might eventually lead to the Big Rip, where space expands so violently that it tears apart galaxies, then planets, and finally the very atoms that make up our bodies. We are living on a ticking time bomb, and the fuse is already lit. Here is a puzzle that is driving astronomers absolutely crazy right now: a crisis in cosmology. Imagine you are measuring a child's height with two different rulers. One ruler says they are 5 feet tall, and the other says they are 5 feet 4 inches. You check the rulers, and both are perfect. This is the essence of the Hubble tension. There are two main ways to measure how fast the universe is expanding. The first method uses the cosmic microwave background, essentially the faint glow left over from the Big Bang that permeates space. This is a look into the deep past. The second method uses bright objects like supernovae and specific types of stars, like Cepheid variables, to create what scientists call the cosmic distance ladder, measuring the distance to modern stars. Both methods are extremely precise and have been checked thousands of times. The problem is that the numbers do not match, and both methods give different answers. The difference is small, just a few kilometers per second per megaparsec, but it is consistent. And the difference is so large it cannot be explained by a simple measurement error. Every single time we check, the numbers disagree. This suggests one of two things. Either there is a systematic error hiding somewhere in our measurement methods, meaning our instruments are lying to us, which is unlikely, or our model of the universe and our physics are fundamentally wrong. Some scientists believe the Hubble tension points to new physics out there that we haven't even dreamed of yet. Perhaps dark energy is changing over time and is not constant. Perhaps there are particles we have not discovered yet. Perhaps the early universe behaved differently than everything we think we know. This data conflict is the loudest signal yet that we fundamentally misunderstand the house we live in. We do not know, and that is the honest answer. Right now, at this very moment, imagine you are on a boat in the middle of a pitch-black ocean. There is no current, no wind, but you feel your boat, and every other boat around you is being pulled relentlessly in one direction. Somewhere over the horizon, something so massive is hidden that it is tugging on entire galaxies. Our galaxy, the Milky Way, is being pulled through space, and so are hundreds and thousands of other galaxies around us. All of them are screaming toward the same point in intergalactic space, about 250 million light-years away, at a speed of about 2.2 million kilometers per hour, or 600 kilometers per second. We call it the Great Attractor. The problem is, we cannot see it. What is there? We do not know, because it sits directly behind the densest part of the Milky Way's core. It is hidden from our sight by the zone of avoidance, a region so thick with dust, stars, and gas from our own galaxy that it blocks out visible light, and our telescopes cannot see through it. We can only detect its immense gravitational pull. When astronomers finally mapped the region using X-ray and radio observations, they found an enormous supercluster of galaxies, a cosmic structure spanning hundreds of millions of light-years known as the Norma Cluster or the Laniakea supercluster. But even its mass is not enough to explain such an incredible pull. That might not be the whole story. There are hints that the Great Attractor itself is being pulled towards something even bigger, something far more gargantuan hiding deeper in the universe. Something beyond what we can currently observe. The universe has structure upon structure upon structure, all connected in ways we are only beginning to understand. We are flying toward the unknown, and we have no way to hit the brakes. This leads to perhaps the most philosophical of all mysteries. The universe is infinite, and it is nearly 14 billion years old. In 1950, physicist Enrico Fermi sat down to lunch with a group of colleagues, and the conversation turned to the possibility of extraterrestrial life. Fermi asked a question so simple and yet so devastating that it has never been properly answered. Where is everybody? Think about it. The Milky Way has somewhere between 200 and 400 billion stars, and most of those stars have planets. Many of those planets sit in the habitable zone, the right distance from their star for liquid water to exist. Some of those planets are billions of years older than Earth. By all mathematical logic, the cosmos should be teeming with life, if even a tiny fraction of them developed intelligent life. And if even a fraction of that life developed technology and started exploring space, then statistically, someone should be here by now. We should have heard signals, detected radio waves, megastructures, signs of colonization, or something. And yet, when we point our telescopes at the sky, we hear nothing but dead silence. The answers to the great silence are terrifying. Some scientists say we are a fluke, and the universe is genuinely empty, meaning we might be the first intelligent civilization, or even worse, the last. There is the Great Filter hypothesis. Perhaps at a certain stage of development, intelligent civilizations tend to inevitably destroy themselves before they can spread. A few argue that something out there is deliberately silent or deliberately hiding, or maybe we live in a cosmic zoo, and more advanced beings have decided not to contact us until we grow up. Or perhaps they are so advanced that we are nothing more than ants on the side of an interstellar highway. The silence of the universe is either a sign of our uniqueness or a death sentence. Speaking of the search for life, we have been scanning the skies for signals since 1960, and in all that time, we have detected exactly one anomaly that has never been fully explained: a missed call. On August 15, 1977, astronomer Jerry Amen was working on the Big Ear radio telescope in Ohio, reviewing data. He was searching for signals that might indicate intelligent life elsewhere in the galaxy, and then he captured something incredible. It was a narrow-band radio signal that lasted for exactly 72 seconds. It was so remarkable, so powerful, and so different from natural background noise that Amen circled the data on the printout and wrote one word in the margin: "Wow." The signal came from the direction of the constellation Sagittarius and perfectly matched what scientists expected to hear from an extraterrestrial alien broadcast. The frequency was exactly what was predicted, close to the hydrogen line, the universal language of the cosmos. Amen and other scientists spent years trying to catch that signal again, pointing the most powerful antennas at that spot and using the best computers. But the result was zero. The signal has never been detected again. It vanished as quickly as it appeared and has never been explained. Natural sources like a random reflection of an Earth signal off space debris have been proposed, but none of them fit perfectly. The signal matched the profile of an intentional narrow-band broadcast almost exactly. We do not know what sent it. We do not know precisely where it came from, and we do not know if it will ever come again. Was it a brief beacon from a distant civilization that accidentally brushed past our planet? For 72 seconds, something in the cosmos sent a signal powerful enough to be detected across hundreds of light years, and then it vanished. This missed call remains the only serious candidate for a message from the stars, but without a repeat, we may never know the truth. In 2007, astronomers discovered something even stranger than the wow signal: cosmic cannons. Imagine a flash of energy, a burst of radio waves that lasts only a few milliseconds, less than a single millisecond. But in that tiny blink of an eye, that fraction of a second, it releases as much energy, or more energy, than our sun produces in 3 entire days, or even 80 years. These are called fast radio bursts, or FRBs. Since their discovery, they have been keeping astronomers awake at night, and we have detected hundreds of them. They are coming from all directions in the sky, from all over deep space, from distances of billions of light years. Most of them appear once and are never repeated. However, a handful have repeated, sometimes with strange mechanical regularity, almost like a pattern. What could possibly generate that much power in a fraction of a second? Theories range from merging black holes to magnetars, incredibly dense, magnetized neutron stars with incredibly powerful magnetic fields. We have traced some to magnetars, but magnetars alone may not explain all of them. Some researchers have quietly wondered and even seriously discussed whether certain fast radio bursts might be artificial in origin, perhaps traces of massive interstellar propulsion systems. The strangest part is that some FRBs repeat on a strict schedule, like every 16 days. In nature, such rhythms are rare. The mainstream scientific community is skeptical, but nobody has fully closed the door. Every time we think we have solved the riddle, a new signal arrives that shatters all our theories. What we know for certain is that something out there is producing the most powerful millisecond bursts of energy in the observable universe, and we are only beginning to understand why. For the final mysteries, we have puzzles that challenge the very foundation of cosmology and are perhaps the most unsettling of all, because it is not about what we do not know. It is about what we do know. According to the cosmological principle, the universe is isotropic, meaning that on a large enough scale, it looks the same in every direction. There is no up, down, center, or special side to the cosmos. But when scientists began studying the map of the cosmic microwave background, they found a strange anomaly. There is a line running through the entire sky, along which the temperature of the radiation is unevenly distributed. It looks as if the universe has a preferred orientation. Scientists jokingly called this the axis of evil because it threatens to destroy our entire understanding of a uniform universe. If the axis of evil is real, it means the universe has a structure that the Big Bang cannot explain. Is our universe part of something larger, or are we seeing the footprint of another universe that collided with ours at the very beginning of time? Every new study either confirms this anomaly or confuses us even more. Coupled with this is the mystery of the fine-tuned universe. The universe runs on a set of physical constants: the strength of gravity, the charge of an electron, the rate at which the strong nuclear force holds atomic nuclei together, and the cosmological constant that governs dark energy. If any of these values were even slightly different, we are talking about changes of 1 part in a trillion, or in some cases 1 part in 10 to the power of 120. The universe as we know it would not exist. If gravity were slightly stronger, stars would burn out in thousands of years instead of billions, leaving no time for life to evolve. If the cosmological constant were slightly larger, the universe would have expanded too fast for galaxies to ever form. No galaxies means no stars, no planets, no us. The universe appears to be precisely calibrated for the existence of life. This can mean one of 3 things. Either it is an incredible coincidence, or there is a deeper physical reason we have not discovered yet, or there are countless other universes with different constants, and we simply happen to live in the one that works. None of these answers are fully satisfying, and each one opens another door into the unknown. The universe is the greatest puzzle ever posed, the greatest detective story ever told, where the clues are scattered across billions of light years, and the witnesses remain silent. We are still barely reading the outside of the box. Dark matter, dark energy, the Hubble Tension, the Great Attractor, the Fermi Paradox, the WOW signal, fast radio bursts, and the fine-tuned universe. 8 mysteries that have occupied the greatest scientific minds of our era, and that remain, as of today, completely unsolved. We live in an incredible era where we are smart enough to ask these questions, but not yet advanced enough to answer them. But here is what is beautiful about all of this. Every single time humanity has found an answer, that answer revealed 3 new questions nobody knew to ask. The universe is not running out of secrets. It is giving them to us, one at a time. Which of these mysteries do you find the most terrifying? Do you believe we will ever find the answers? Or are some doors in the universe meant to stay closed? Let me know your thoughts in the comments. I'm genuinely curious what you think about the Great Attractor or the silence of Fermi. If you want to keep exploring and enjoyed this dive into the unknown, hit the like button and make sure to subscribe. There is a lot more universe waiting. We are only just beginning to explore this giant mansion called the universe, and there are many more rooms we have yet to enter. Thanks for watching until the very end. See you in the infinite.